Okay, well, let's do another one. Let's say for some reason we're particularly interested in two individuals in the population, and we want to know what's the chance that those two individuals do not coalesce until the last event. Okay, so this individual could coalesce with anybody else, this individual could coalesce with anybody else, but that these two do not come together until the end. All right, so in the first, so what has to happen in order for that to be the case? These two individuals have to not coalesce at the first event, they have to not coalesce at the second event, they have to not coalesce at the third and the fourth until the last. So what's the chance that these two individuals do not coalesce in the first event? Well, that's equal to n minus, so notice that in this case, anything is fine. This one can coalesce with 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 whatever, just as long as these two don't coalesce. So we're going to pick a random pair here, and it just has to be any random pair except for this one. Okay, so how many random pairs do we have? We said we have n, choose two random pairs. And so in this case, what we need is n, choose two random pairs, any one of them except for this one. So that's n choose 2 minus 1. Okay, so that's the probability. So the first coalescence occurs, in this case, it includes these two individuals, it actually includes neither of these. That's fine. So now in the next generation, okay, so now we have n minus 1 lineages, and so we have n minus 2, choose 2 pairs that are possible, of which any of them is fine. This can coalesce with this can any of them is fine except for this coalescing with this. And so again, now we get n minus 1 choose 2 minus 1 divided by n minus 1 choose 2 minus 1. And they both have to happen, so we're going to multiply them. And so what we're going to get is this series until we get to the last one. Right? So it's going to be, this is 6 individuals, so it's going to be the first 4 individuals, so it's going to be all this multiplied together. And then the last one is going to be 3 choose 2 minus 1 divided by 3 choose 2. Yes, that's right. Okay, so let's multiply all this out. So first let's expand this. So this is equal to n times n minus 1 minus 1. So each one of these is going to be expanded like so. Okay, so we can start out by multiplying everything through by 2 to get rid of these 2's. And so we end up with n times n minus 1 minus 2. So this is equal to n squared minus n minus 2, which can be factored as n minus 2 times n plus 1. Is that right? I am doing this on the fly here. Yeah, that's right. What do you know? Yep. Okay, so this thing here can be simplified to n minus 2 times n plus 1 over n times n minus 1. Okay, so I'm just going to move this over here. So what we've just shown is that some number x divided by 2 minus 1 is equal to x minus 2 times x plus 1 over 2. Okay, so we can do that for each of these numbers. So then we get n minus 2 times n plus 1 divided by n times n minus 1. Okay, so the next one down, now everything just goes down by 1, so we get n minus 3 times n minus 1 plus 1, which is n, divided by n minus 1 times n minus 2. Okay, let's just carry this out for a while. So this will be n minus 4 times n minus 1 divided by n minus 2, which is n minus 3, times n minus 5, n minus 2 over n minus 3, n minus 4. So we're starting to see a rhythm here, a pattern, where we can see that some of these things can cancel. But it's a little bit more complicated because this can't cancel with what's underneath it. See, none of these are the same. But this can cancel with this, and this can cancel with that. Next term over. This can cancel with this, and this can cancel with that. Okay, next term over. This can cancel with this, and this can cancel with that. And so what are we left over with here? Well, we're left over with 1 extra n plus 1 over n minus 1. And if we continue it out to the end, we'll see here, so this is equal to, so for 3, so this last term that we have is equal to n minus, sorry, not n, is equal to 3 minus 2, 1, times 3 plus 1. 4, and then on the bottom we have 3 times 2. Okay, so the what's not going to cancel, notice it's always this left one, it's these left 2 that do not cancel. So we're going to end up with a 1/3 from over here, and then over here we end up with n plus 1 times n minus 1. And so our overall estimation is n plus 1 over n minus 1 times 1/3. So, sorry, that's gone off the screen, so I'll write it up here. So overall, we get n plus 1 times n minus 1 from these terms. And then if we go all the way to the right, we end up with these other terms, 1 divided by 3. Okay, so I don't think I did a great job of that. I'm not going to stop and do it again. Because we have a lot to cover. So the point here is not, what I'd like people to see here is not the exact result, because this exact result you're unlikely to need in your research. But what I want people to see is that it's possible to ask these questions. What's the chance the tree has this kind of shape to it? Or what's the chance that the relatedness between these two individuals is such and such? And then we can write down some stuff that looks nasty for a minute, and then simplify it, and we often end up with these very simple expressions. So, sorry if I got something wrong here, or if it wasn't particularly clear, but that's the main point of the lecture. And I would suggest that if people want to dig in even more, that you could try to do this by yourself and see if you can get through it.